Our topic for today is all about the law of conservation of mass. The learning objectives are students will be able to explain the law of conservation of mass, and students will be able to solve simple problems regarding the law of conservation of mass. A scientist who was recognized as the father of modern chemistry, Antoine Lavoisier, recognized and named oxygen and hydrogen, and he also developed the metric system, and through his experiments confirmed that although matter may change its form, the total mass remains constant. So the law of conservation of matter states that the total mass of matter remains constant whether it takes um, it can also be stated as mass is never created nor destroyed. So here you have the mass of the reactants is equal to the mass of the products. According to the law, the mass of the reactants, in this case reactants 1 and 2, is equal to the mass of the product. So examples here we have 20.0 grams plus blank is equal to this mass right here. So pertaining to this reaction. But first, let's go back to this one right here. In the lab, mass is measured in, answer for this is gram, Gram, or kg, or you say kilogram, Kilo, and then the word gram. Mass is measured using either A, triple beam balance, or an electronic balance, or you say a scale. So back to this one here. So if you have 95.6 grams of the product, so you have to use your calculator. So what happens right here? What should be the mass of one of the reactants? In this case, reactant 2, for you to follow the law of conservation of mass. So you have 95.6 grams, subtract their 20.0 grams. Therefore, this mass right here for the reactant 2 should be equal to 75.6 grams. Now let's take letter B. For letter B, you have here 15 grams. So you have here, you don't know the mass of reactant 1. So therefore, what you need to do is to find it out to make them equal or the same. So the right side must be equal to the left side for them to have that sign equal sign. So 15.00 minus 7.36 is equal to 7.64 that go to this blank right here, which is the mass of reactant 1. Easy, huh? Okay, let's go to the third example. For the third example, you don't know what the mass of the product is, but following the law of conservation of mass, you know that you just add these two, and then you now get the mass of the product. So therefore, you have 4.1 grams plus 55.0 grams is equal to 259.1 grams, and that is now the mass of the product. Okay, and this is a simple application of the law of conservation of mass. You can like encounter problems, word problems in the assessment, but the same is the concept that go with it. And what is the concept? That the mass of the reactant should always equal the mass of the products. So does it only apply to one reactant and two reactants and one product? No, it can be one reactant and then you can have two products because there are different types of reactions. You know, you have combustion reaction, you have decomposition, combination, single replacement, and double replacement, and you will know all of those, okay, types of reaction. You don't need to learn them now. So when we speak of reactant, it goes to the left side of the equation where the arrow came from. And wherever the arrow is pointing at, that one is your product, okay? So in this example, I just made one product, but it can be two products, three products. The left side can have like one reactant, two reactant, three reactants. It all depends upon what the reaction is. And then finally here, which scientists results below best support the law of conservation of mass? So what you need to do now is to just add reactant 1, reactant 2. It should be equal to the mass of the product. So give you time to do that. A little bit of wait time here. Use your calculator, or you can just do it in your head, the computation. What do you think? Which scientist results below best support the law of conservation of mass? Are you done? Yes, you are right. The answer is D. Why? It's because if you add 19.364 19.364 grams plus 22.372, the answer is 41.3.736. Typo error, guys. It should have been 41.376. Okay. And this one should be changed right here, huh? Again, this one should be 41 point. That one there should have been 3, 7, 736. That should have been 7. And then this one here should have been 36. Okay. So again, let's go back to the stuff right here. So it should be in grams. Okay, this one should be grams, and the symbol of that one is G. And this one here is kilo, okay, grams, or that should be small letter K, small letter G. And let me just adjust this one so that you can see them all. Okay, where's that one again? So let me just adjust it and so that you can see it. Okay, so adjust it and change the size of that one so you can see it. Okay, there you go. Going in the lab. Okay, there you go. In grams, G, or there you go. And you can even highlight this one. Okay, so highlight that one in, say, green. So you can see it right away. And this one, gram as well. Okay, highlight in green. And this one right here is kilogram, and we can highlight it with a different color. Like what color? Say a blue one. Okay, and then this one here is measured using a triple beam balance. So you have your balance. Okay, and the other one should be a scale. Okay, so those are the ones, and of course, we can always like answer this one again later on, and I gave you the answers for this as well. These are simple application of the law of conservation of mass.